Okay, this is the 2014 paper that was on iLearn. I'm just going to go through and just do the whole paper now. I'll be moving through fairly quickly, so if you have trouble with something, make sure you rewind the video and just have a look at it. So starting with section 1, computations of fractions and decimals. Make sure you give your answers in the simplest form. Starting off 2/3 plus 5/3. 2/3 plus 5/3, denominator is the same, so we can go simply and add the numerators. 2/3 plus 5/3 equals 7/3. And in simplest form, we have 2 and 1/3. So that's our answer, 2 and 1/3. Next question down, 3 and 4/5 minus 1 and 1/4. Now we need to change our denominators here to be able to make it the same. So let's just do the denominators first. Let's make it to the base 20. So we times that by 4, times the top by 4 as well. So we have 16 over 20, 3 and 16 over 20, minus 1 and 5 over 20. That'll become, once we times the bottom of the top by 5. And so now we can do our fraction subtraction first. We're left 16/20 minus 5/20 is simply 11/20, and 3 minus 1 is 2, so we have 2 and 11/20. Now this can't be simplified, so we're okay the way it is. Now we have a decimal problem. Now you might not be able to see these. Let me write it a little bit bigger. 10.8 plus 0.04 plus 1.2. Let's simply put them in an algorithm with everything in the right column. 10.8, 0.04, 1.2. Add some zeros there to make it nice and even. 4, 10, carry the 1, 2, 1, and our decimal point carries down, so our answer is 12.04. Now keep in mind, guys, I'm going through this fairly quickly and it's fairly late, so I might make a mistake here and there. I'm sure you guys can verify with your calculator, but what you really need to be learning is the method for each of them. So if I make a silly mistake, feel free to come at me and send me an email, tell me I'm wrong, but make sure you pay attention to the method. Now again, we're doing our multiplication with decimal. I'll write this a little bit bigger so you can see it. 0.07 times 0.7. Simply use our algorithm. 0.07 times 0.7, and we need to add a 0 there. So we have it even. Our first row is going to be all zeros. Add our automatic 0 to go up to the next one. 7 sevens 49, carry the 4, 49, 0. Add all these together, 0940, and we count 1, 2, 3, 4 numbers after the decimal points. So we go 1, 2, 3, 4 points where we move it. So our answer here, right over this place, our answer is 0.049. 0.049 is our answer. Once again, now we've got a division question. We've got 5.95 divided by 0.5. Now remember, when we're dividing our decimals, we need to make the number at the front a whole number by moving the decimal point. We move it one space to make that 5. So we need to move this one space to make that 59.5. Now we can just do 5 into 59.5. 5 into 5 goes once. 5 into 9 goes once with 4 remainder. 5 into 45 goes 9 times. So our answer is 119. 11.9. We need to make sure we carry our decimal point back up to the top there in the same line. 11.9. And you can verify that by doing 11.9 times 5, and you should get 59.5. Okay, next page. Question at the top. We have 1/4 divided by 1/8. That's part F, 1/4 divided by 1/8. Remember, we don't divide fractions, we multiply by the reciprocal, and we need to find the reciprocal of that number. So we have 1/4 multiplied by the reciprocal of 1/8 is 8 over 1. And so we have 1 times 8 over top, 4 times 1 on the bottom, 8 over 4, which is simply 2. Okay, next one here we have 28 over 45 times 15 over 63. Again, multiplications are the easiest thing to do with fractions. We do the top times the top and the bottom times the bottom. Now I'm going to need to bust out, some algorithms over here to be able to do these. 28 times 15, 5 8s are 40, 2 5s 10, 14. Automatic 0, 1 8, 2, 0, 12, 4, 420 on top. And 45 times 63, let me do it over the space over here. 45 times 63. 3 5s are 15, 3 4s are 12, 13, automatic 0, 6 5s are 30, 4 6s are 24 plus 3 equals 27. So 5, 3, 8, 2, 420 over 2, 8, 3, 5. And that's going to, of course, need some simplification. First, it's divisible by 5, so if we divide it all by 5, then we'll get to that. I'm not going to worry about simplifying this answer here. I'm simply going to manually, you guys can do that on the test. I'm simply going to tell you what the answer should be. Our answer here is simply going to be 84 over 1367. We just divided them both by 5. Quite a complex question, quite a complex answer. It's a bit of a strange question. Okay, so now we have 1/3 minus 3/4 plus 1/6. 1/3 minus 3/4 plus 1/6. Now we can do this in any order. We can do the subtraction first or the addition first, but we need to make sure that we're modifying all our denominators. Now our denominators can all go to 12. We all have the lowest common denominator of these 3 to 12, so let's make it all 12 so we can simply do it easily. Times that by 4 and by 4, by 3 and by 3, and by 2 and by 2. So our fractions would be 4 over 12 minus 9 over 12, 12 plus 2 over 12. 4 minus 9 is -5, plus 2 is -3, so it's -3 over 12 is our answer. 0.75 plus 3/8. Now the fraction form of 0.75 is 3/4, and so now we can add them together after we've changed our denominator. 6 over 8 plus 3 over 8 equals 9 over 8, or 1 and 1/8. 0.4 repeating plus 0.7 repeating. Now, I find the easiest way to do these repeatings is to, sorry, let me move that down a little bit. The easiest way to do these repeatings is to do an approximation of each of them. So this is approximately for 0.4444, and of course it continues on, and we add that to 0.7777, and of course that continues on, but we're just approximating them for now. So if we added these up, again, 4 plus 7 is 11, carry the 1. 4 plus 7 plus 1 is 12, carry the 1. 4 plus 7 plus 1 equals 12, carry the 1. 12, carry the 1. And so we have our answer here is actually 1.222. And imagine if we had another 7th here and another 4 there, this wouldn't be a 1, it would be a 2. So imagine if we continue on the 4s and continue on the 7s, we're just going to have a bunch of 2s. So our answer is 1.2 repeating. Okay, 1.2 repeating. That's the end of section 1. Let's go to section 2, which is a measurement. So here we go, 9 centimetres in millimetres, that's 90 millimetres. 45 centimetres is 0.45 metres. Yeah, we move our decimal point 2 places. In this we move our decimal point from there, we go back 1. Here we go forward 2. Kilometres to centimetres. Okay, well, there are 1,000 meters in a kilometer, and there are 100. So if we go from kilometers to meters, we would have 2,345 meters, 2,345 meters. But in centimeters, if we add another 2 zeros onto that, move it another 2 places, then we'll get it in centimeters. So our answer is 2,345, 0, 0 centimeters. Express a fraction, 83 centimeters of 1 kilometer. Okay, so once again, very similar to this question here, kilometers and centimeters. Expresses a fraction, 83 centimeters of 1 kilometer. Okay, 83, we know it's going to have the numbers 83, but now we just got to count how many zeros. Okay, so that would be 0.83 would be meters, and so we're going to have to add 2 more zeros to be 0. I think that's right. I've just realised my mistake here. It says express as a fraction rather than express as a decimal. So this is the decimal form of it. But as a fraction, this is going to be tenths, hundredths, thousandths, 10,000ths, and 100,000ths. So it's 83 100,000ths. There are 100,000 centimetres. Shouldn't put my comma in there. There are 100,000 centimetres to a kilometre. There's 100 centimetres to a metre and 1,000 metres to a kilometre. That makes 100,000. And so this is it as a fraction. Can't be simplified, so we just leave it like that. Which metric unit would be the most suitable for measuring the real life length of the college swimming pool? Well, metre is going to be our best one. Yep. Because of course we have a 50-metre pool. Peter needs to purchase some timber to construct a fence for his home. If one piece of timber is 1.2 metres long, how many pieces of timber does he need to buy if he needs 26.4 metres of fence? Okay, so we have some kind of fence. The perimeter of it is 26.4 metres. Now, and each piece of wood, we'll call them X, is 1.2 metres. And we need to work out how many X's do we need to do 26.4. We can simply do this with a division question. 26.4 divided by 1.2. That'll tell us how many pieces of wood we need. Once again, we have to move that decimal point over one space because we need a whole number. We do the same over here. 12 goes into 2 0 times. 12 goes into 26 2 times with 2 remainder. And 12 goes into 24 2 times. So we need 22 pieces of timber. Okay, and that's our answer, 22 pieces of timber. Now down the bottom here, if a piece of timber costs $3.45, what will the total cost of the timber be? Well, of course, we just need to do $3.45 multiplied by 22. Okay, well, let's actually do these the other way around because it's always slower, I find, to have our small number at the top. So we'll do our big number at the top with our multiplication. 0, 0, 10, carry the 1, 11. Automatic 0, 0, 0, 8, 8. Automatic 2 zeros, 0, 0, 6, 6. 1, 2, 3, 9, 15, 7. And we have 1, 2, 3, 4. 1, 2, 3, 4. Right where we would expect it to be. That's $75.90. Make sure we put our dollar signs there because it asks us what will the total cost be. So if we didn't give our answer in dollars, then we're not going to really make much sense. That's section 2. Let's do section 3, which is algebra, my favourite. Let a number be represented by the pronumeral n. Write down the algebraic expression for the following. 4 times a number. So we're saying that our number is n. So 4 times a number is 4n. A square of twice the number. Okay, the square of twice the number. So we need a square of something. A square of what? A square of 2 times the number. Is x a factor of 12x? Well, if we want to make 12x, we can get 12 multiplied by x and get 12x. So yes is our answer. X is a factor of 12x. You would simply need to write yes there. I just want to show you that if we can multiply it to give that answer, then yes, it's a factor. Write down one other possible factor of 12x. Well, 12. You could also put 2, you could also put 6. Any of the factors of 12 could be put there. I think putting 1 is probably a bit of a cheap one to do, because of course everything has a factor of 1, so that's a bit of a cheat sheet kind of thing there. I guess it's technically right, but you're probably going to want to give a more intelligent answer than the number 1. Simplify the following. Where's our like terms? First off, our y and a y term, and a number term, or a constant and a constant. 3y minus y, plus 4 minus 4. Now our plus 4 and minus 4, they cancel out, leaving us just with 3 lots of y minus 1 lot of y. So our answer is 2 lots of y. Again, our like terms, negative 2x squared and positive x squared, and our negative 3x squared and negative x squared. Negative 2x squared plus x squared, negative 3x, negative x. Okay, combine these ones and we get just negative x squared, because we have negative 2x squared plus x squared, and combine these two and we get negative 4x minus 3 minus x is minus 4x, and that's our most simple answer. Now, when we have things up on top and bottom of the fraction, let me just move that up a little bit. Up on top and bottom of the fraction, we cancel out the common factors. A and A is a factor, so they can be cancelled out. And 4 and 2 have a common factor of 2, so we cancel that out to be a 2 and that out to be a 1. So we're left with 2b on 1a, which is just a. Okay, most simple answer. Simplify this one, 3m times 2n minus 2. Well, we need to multiply all of our constant terms together, all of our numbers, or our pronumerals, whichever way you want to call them. So we have minus 2 times 3. That's negative 4, negative 12. And our pronumerals are m and n. So our answer is negative 12 mn. Okay, putting all those factors together. Now, here we have 4xy minus 4xy divided by 4. Now, order of operations dictates we do this part first. Okay, so let's put that in brackets, and we'll do that first. And then we'll have 4xy minus whatever the answer of that is. Now, 4xy divided by 4, we could also write it like this, fractional form. And just like our one up here, the 4 and the 4 are going to cancel out, simply leaving us with just xy over 1, which is just xy. And so our whole answer has become this 4xy minus just xy, which is just 1xy. And so we're left with 3xy. Okay, substitution. Given that a equals 4, b equals minus 2, evaluate the following. So a equals 4, b equals minus 2, so plus minus 2, same as 4 minus 2, which equals 2. Now, this one we have to be careful. This is a times b squared. It is not a times b all squared. Okay, so 4 times negative 2 squared. What's negative 2 squared? Well, it's 4. So it's 4 times 4, which equals 16. Okay, next page. Last couple of questions. Expand the following, fully simplifying your answer where possible. Now we remember when we have a number next to a bracket like this, we multiply the outside term by each term individually, making sure we account for the positive and negative numbers. So we want 4 times a and 4 times minus 3. Okay, 4 times a plus 4 times minus 3 is going to be 4a minus 12. 4a minus 12. Negative 2x outside of x minus 3y. Well, we have negative 2x times x, and then we have negative 2x times negative 3y. Okay, so negative 2x times x is negative 2x squared, and then we have two minuses multiplied together make a positive, and it's 6. 2 times 3 is 6, and xy are our terms, they are our pronumerals. Now this bottom one, we've got some order of operations. We have a multiplication in the middle here, so we do this part of it first, making sure we account for this negative here. So let's do the question. Let's do 12 times, we have a 12 minus in front. Let's do 12 times 1. Put a big square bracket there to make sure we keep it separate. 12 times 1 plus 12 times minus 2x. Now, whoops, square bracket. Now notice I haven't done negative 12 in each of these. I've simply kept the negative out the front there and just made it positive 12. That's fine, I can do that if I wish, but I need to make sure that I don't lose that negative somewhere in the trip. So now we have 12 minus, and I'll just use regular parentheses at the moment, 12 minus 12 plus 12 times negative 2x is going to be negative 24x. Again, big parentheses on the outside. So once again, 12 minus 12, and we have to apply this minus in here. And so that minus to that part here goes minus a minus, which is plus 24x. Now that might have seemed confusing to you. Let me do that once again. So this was plus a minus 24x, so that was just a big minus in the middle there. Okay, it was like 12 minus 24x inside the brackets. But this minus out the front, it applies to that and to this. So the minus a minus made it a plus in the end. 12 minus 12, our answer is simply 24x. That's our final answer. Okay, that was section 3. Now let's go on to section 4, equations, my other favourite. Okay, solve the following equations by inspection. So let's just move some stuff around. We have a minus 11, let's make it a plus 11. Minus 11 plus 11 equals 43. Plus 11, cancel, cancel. That gives us A equals, notice I didn't make that an equal sign, it's an arrow because we want to have an equal sign kept properly. 54. Now we can do this a little bit quicker. 5 lots of B, let's divide it. Let's divide by 5. B equals 45 over 5, and we divided by 5 over there, so B equals 9. 6 minus C equals 10. Now be careful not to lose your minuses there. Minus C equals 10 minus 6. And so negative C equals 4. But we want to find positive C for our answer. So positive C must equal negative 4. We simply multiply both sides by minus 1. Well, we simply think logically, if negative C equaled positive 4, then positive C would equal negative 4. Okay, D over 4 equals negative 1. Simply multiply both sides by 4. D equals minus 4. 3E plus 1 equals 13. Let's get rid of the 1 first by taking it away from both sides. And then E can simply be, we can simply divide that side by 3. So E equals 4. F divided by a quarter, well, let's not worry about doing the reciprocal and all that kind of stuff. Let's just times it by a quarter on both sides. F equals 20 times 1/4. Well, times by a quarter means what is 1/4 of 20? So F equals 5. 1 over P plus 1/2 equals 1. Let's take away the half from that side first. 1 minus a half. So that means that 1 on P equals 1/2. Now, if we have two fractions like this, they're isolated, then we can flip both of them. P over 1 equals 2 over 1. Therefore, P equals 2. Now, remember, you can only do that when you only have a fraction. If you had something like a -1 or a 3 plus over this side, you wouldn't be able to do that. Only when it's like this. Only when you have a fraction equals a fraction. I just realised I've done that whole thing with the thing off the screen there, so that's what it looks like. Hopefully you're able to follow along. Minus the half over to that side, and then we're just left with that. Flip both of them over, and our final answer. Okay, solve each below. All your working must be shown. Now these are 2 marks each. Make sure you show your working. 3g plus 2g. Let's add our g's together. 5g equals 15. Divide both sides by 5. G equals 3. Okay, if you went straight to that, you would not get the full marks. 2h plus 15 minus 15 equals 57. Oops, 50. 7 minus 15. 2h equals, what's 57 minus 15? That's going to be 42. Okay, 2h equals 42, therefore h equals 21. Multiply in, 4 times m plus 4 times 3 equals 20, so 4m plus 12, 20 equals 20. Take away 12 from both sides, 4m equals 8, m equals 2. Now, this bottom one, write an equation to solve. 7 is subtracted from k. The result is tripled, giving 18. Okay, so 7 is subtracted from k. That means we have k, and we take 7 from that. The result is tripled, so 3 times that, giving 18. Okay, 7 is taken away from k. The result to that is tripled, so the bracket is tripled, giving 18. So there's our equation for that one. And that was equations. Section 5 is indices. Section 5 is indices. Okay, so indices, nice and easy. Expanded form, we get some multiple choice. So 5 to the power of 6 in expanded form is 5 times itself. 6 times, 1, 2, 3, 4, 5, 6, so C is our answer. 10 to the power of 4, the base numeral is given by which one? Well, our base numeral is the one here to the index, so B10 is our base numeral. List all the prime numbers between 12 and 25. Remember, prime numbers are only divisible by themselves and 1. So we have 13, 17, 19, 23, and that's it. Yep. 13, 14 is divisible by 7, 15 is divisible by 3, 16 is divisible by 8, 17, 18 is divisible by 9, 20 is divisible by 10, 21 is divisible by 7, 22 is divisible by 11, so these are the only prime numbers between 12 and 25. Express 80 is a product of its primes. Now we did this in semester 1, so I'm not going to bother doing that one. So that's not applicable to us. They simply did that last year. Let's go to the next page. Evaluate, which means we need to find the answer. 5 squared plus 12 squared. Well, 5 squared is 5 times 5 plus 12 times 12. 25 plus 144. Our answer is 169. Express the above number as a perfect square. Well, 169 just happens to be 13 times 13. So 169 as a perfect square is root 169. Okay, or sorry, I should rather say as a perfect square, 13 squared. Yep, equals 169. Now, I find it strange, express the above number as a perfect square. It should be, the question really should be asking, is the number above a perfect square? And the answer would be yes, it is a 13 squared equals 169. Perfect square is not a form of a number, it's simply a quality for a number, like a prime. It'd be like asking you to write 10 in a prime number format. It simply doesn't work like that. So just a bit of a funny worded question, but just to show that 169 is 13 squared. That's good enough for me. Evaluate 2 to the power of 5 plus 3 to the power of 4. Now we're going to have to do a lot of doubling here. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2 plus 3 to the power of 4, 3 times 3 times 3 times 3. Now 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have 32 plus 3 times 3 is 9, 27, and that would be 60 plus 21 is 81. So 32 plus 81, 111. This is where my mental arithmetic's going to fail me, so you guys check stuff with your calculator, make sure I'm getting it correct. Okay, the square root of 144 plus 3 cubed minus 1 squared. Square root of 144 is 12 plus 3 cubed. Well, 3 cubed was 927 plus 27 minus 1 squared. Well, 1 squared is simply 1. 12 plus 27 minus 1. 12 plus 27 is 39 minus 1 equals 38. Now, whatever is underneath a square, whatever is underneath a squared sign, a square root sign rather, we consider to be in brackets. So we need to do what's under the square root sign before we can do the square rooting. So let's do 10 squared plus 5 squared divided by 5. 10 squared is 100, 5 squared is 25 over 5. So 125 divided by 5 is simply 25. Okay, so the answer to this part is 25. Now we haven't done our square root yet, so we need to do the square root of that, square root of that, square root of that. So our real answer is square root of, our real question is square root of 25, and so our final answer is 5. We must get to that to be able to get our mark. Evaluate 13 to the power of 11 times 13 to the power of 4. Remember, when we have our indexes multiplied together with the same base number, we simply add the indexes, and it says leave our answer in index form, so we don't need the number answer, we just need the evaluated index. So 13 to the power of 11 plus 4, our answer is 13 to the power of 15. Do I have a second sheet, or was this already the second sheet? No, that says end of section 5, so we're done there. Section 6. Time and reading tables. Okay, consider the following. Complete the following. 2 hours and 13 minutes in minutes. So 2 times 60, there are 60 minutes in an hour. So 2 lots of 60 plus the 13 extra minutes. So we have 120 plus 13, it's 133 minutes. 16 days in hours, well, 16 times 24, let's do that over here, 16 times 24, 4 6s are 24, 4 1s are 4 plus 6, automatic 0, 2 6s are 12, 2 1s are 2 plus 1 equals 3, 4, 8, 3, so we have 384 hours. Now there are 365 days in a year, 365 days in a year, and if we do, we need to work out how many years are in this number of days. So 365 days per year, and how many lots of 365 is in this? Well, there's 2 lots because 365 times 2 is 730, so it's just 2 years. Convert this to AM PM time. 2300 hours and 17 minutes is 11:17 PM. Okay. Now we remember that simply 12 midday plus whatever our rest of here, which was 11:17, is going to give us our 24-hour time. So, you know, our 12 o'clock midday plus that, if it's in a PM time, is going to give us that. So we simply work back the other way. We take away 12 and we find out what's left. Take away 12 from this, we would get 11:17 PM. Okay, convert this to 24-hour time. 1:13 PM. Well, how much past midday is that? It's 1 hour and 13 minutes past midday. And so we had to do 12 midday plus 1 hour 13. So our answer is 13:13. We don't have any PMs or AMs because, of course, it's 24-hour time. How many hours are there between the start of school Monday at 9 AM until the end of school Tuesday at 5 PM? So let's do Monday and Tuesday separately. How many hours in between that? So from Monday 9 AM, and let's do it until midnight. So from 9 a.m. Monday to 12 a.m. or 12 midnight is, well, how many hours are there between 9 a.m. and midday? There are 3 hours until midday, and then 12 hours until midnight, so a total of 15 hours. And on Tuesday, from midnight that night, or midnight that morning, until 5 o'clock in the afternoon, well, there are 12 hours until midday, and then 5 more until 5 in the afternoon. So 15 hours on Monday, plus 17 hours on Tuesday, is going to be 32 hours total. Okay, that is our answer, 32 hours total. Sydney is classified in the time zone. Sydney is classified in the time zone of plus 10 GMT. Argentina is minus 3 GMT. If it's 11 p.m. in Sydney, then what is the time in Argentina? Okay, so we need to work out how many hours are there between these. So we start at 0. We are up here at plus 10. And they are back there at minus 3. So there are 13 hours difference. They are 13 hours behind in Argentina compared to what we are. So at 12 midday for us, they are 13 hours behind, which is 11 p.m. Now, so if it is 11 p.m. in Sydney, what time is it in Argentina? Well, what's 13 hours behind 11 p.m.? Well, it's 11 hours from 11 p.m. It's 11 hours to midday, and then we need 2 more hours past that, so it's going to be 10 a.m. is 13 hours behind. 10 a.m. is 13 hours behind. So at 11 p.m. it is 10 a.m. in Argentina. What time is it in Argentina? I'll put it up here, 10 a.m. and I'll put a circle around it so my marker knows which one they're meant to be marking. Now we've got a big timetable here. You guys are going to have to look at your copy because of course it's not big enough to fit on the screen or to be able to see on the screen. If you arrive at Lidcombe station at 14:20, which is 2:20 in the afternoon, what is the earliest you can arrive at Redfern? Well, let's look for Lidcombe first. There it is, and we arrive there at 14:20. So 13:44 too early, 14:14 too early. This is the next train we can catch, but does it go to Redfern? Well, where's Redfern? It's all the way down here. This train does go to Redfern. It gets there at 15:32. So the earliest we can arrive at Redfern if we get the next train after we arrive at 14:44 is this 15:32. So we can get to Redfern at 15:32, which is in 24-hour time at 3:32 in the afternoon. Train from Liverpool leaves at 14:47 and 14:58. Both run different routes. Which train would give you the shortest train ride to Central? So we need to look at what the time difference is between the 14:47 and the 14:58 to Central. Let's find those two trains. Okay, so Liverpool, there's Liverpool right at the top. The 14:47, which is this one, and the 14:58, that's those trains. Now, where is Central? Central's all the way down the bottom. Okay, so we're going from the very start of the line at Liverpool to the very end of the line at Central. 14:47. Well, this one arrives at Central at 15:51, and this one arrives at Central at 15:57. So we need to work out the time difference between those because yes, this one arrives first, but it also leaves first, so it's not necessarily a shorter train ride. Okay. Okay. Let's do the time difference. For this one here, 15:51, we're going to minus 14:47 from that, and that'll get us the time difference. Our answer is 1 hour and 4 minutes. 1 hour and 4 minutes. That is for the first train, 1 hour and 4 minutes, so there's one answer. And this one, 1558 minus 1557, that's only 1 hour and 1 minute. Okay, between those two times is only 1 hour and 1 minute. So the 1458 is the train we want to catch because it has the shorter train ride, only by 3 minutes, but 1458. So we want to catch the 1458 because that will get us the shortest ride. Make sure you make this clear because this is not answering a question. We need to answer the question of which train would you give, which train would give you the shortest ride to Central. We need to catch the 1458. Hopefully that was on the screen. I'm not sure if it was completely, but I'm not going to do it again. If you need to get from Bankstown to Redfern and you need to arrive prior to 3:30 p.m, what's the last train you can catch to arrive on time? From Bankstown, where's Bankstown? There it is, Bankstown, right here. And we need to get to Redfern, which we knew was down the bottom. Bankstown to Redfern, from here to here. You need to arrive prior to 3:30. Well, let's have a look at Redfern. 3:30 p.m. is 15:30. So 15:32, that one's just too late. So we have to arrive at 15:17, and that leaves Bankstown at 14:45. The last train we can catch is the 14:45 from Bankstown. Or simply put 14:45. I'm sure they'll give you that one. Last section. Thank goodness. Divisibility tests. We don't need to do that one. Divisibility test. Don't do that one. We also don't need to do these divisibility tests. We do, however, so we can't do. We're not having to do any of those because they're not applicable to what we've studied this year. However, we are going to do this next one and these two as well. So, subtract this term, this expression, from that term or that expression. So, this from that means that this part comes first. 5 minus x, keep it in its brackets, minus x squared minus x plus 5. Now, if we have a minus at the front of our bracket, we need to make sure we apply that minus to every term on the inside. Okay, let's get rid of our brackets completely so we can do that correctly. Minus x squared plus, minus and a minus makes a plus, x minus 5, minus and a plus makes a minus. Now we've got rid of our brackets, we can collect things. Here are some like terms. Here are two other like terms. Positive 5 and negative 5 cancel out. Negative x and positive x cancel out, simply leaving us with negative x squared. Okay. Negative x squared. Pair of consecutive numbers. This last one down here. A pair of consecutive numbers has a product that equals 2 and a sum that equals 3. Let n represent one of the numbers. Write down two equations that represent the above information. Okay. Pair of consecutive numbers. So our numbers are going to be n and n plus 1. Okay, so n and n plus 1, because n plus 1 is the next number, is what consecutive means. You could also say n minus 1, but there's no real reason why you would do one over the other. So here's our consecutive numbers. And we're told that product equals 2, so n times n plus 1 equals 2. If we simplify that, we have n squared, remember that's going to be bracketed, sorry, n squared plus n equals 2, and a sum that equals 3, so n plus 1 equals 3. n plus 1 equals 3, and simplify that again is 2n plus 1 equals 3. Find the two numbers. Now, this is a tough one. Simultaneous equations is something that you guys will do later in mathematics, but for now we're not going to do simultaneous equations, but we need to find clues. So if we solve this bottom one, if we solve this for n, which we can do, then we can substitute the number for n into our top equation. And, well, actually, if we find our answer here, then we don't really need to do anything with this top equation. So this bottom one can be solved, okay? This top one we can't solve as easily because it has that squared term in there. So let's do this bottom one. 2n plus 1 equals 3. 2n equals 2. N equals 1. So n equals 1. 1 is our first term. What was our second term? N plus 1. So, of course, n plus 1 equals 2. So that and that are our two terms. Okay, find the two numbers, 1 and 2. Okay, and that's it. So hopefully that helped. Once again, send me emails, ask me questions, do whatever you need to do to be able to be prepared, and I hope this video has been helpful for you. Bye.